Okay, so remember 8 plus 5 means replace the x with 8 plus 5. So this is 2 times 8 plus 5 minus 1. So I get 2a plus 9. X plus h, same thing. It's just x plus h instead of 8 plus 5 or whatever. For letter C, remember, we have to FOIL that first. That's a squared minus 2a plus 1. Again, the reason why I have you memorize that is how much it comes up. And that is a squared minus 2a minus 3. All right? Okay, letter D. So f of x is 3x minus 5. F of a is basically you just replace x with a, so 3a minus 5. All of it over x minus a. So you have 3x minus 5 minus 3a plus 5. Your 5's will cancel. You're left with 3x minus 3a. And then if you factor out the 3 from the top, the x minus a cancels, and you're left with 3. This is something that you're going to need to know how to do if you ever take calculus, so that's why we're going over this. F of x plus h is x plus h squared minus 4, which is x squared plus 2xh plus h squared minus 4. So you have this minus f of x, which is x squared minus 4, all over h. Okay, simplify. So x squared plus 2xh plus h squared minus 4 minus x squared plus 4. And then just start simplifying. Your x squareds cancel, your 4's cancel. You're left with 2xh plus h squared over h. If you factor out an h from the top, you're left with 2x plus h. Okay, and then when you look at 2, it's just plugging in and then simplifying. So no different than what we've been doing. All right, looking at 4, let s of x equal this and t of x equal this, so find that. So this is s of t of x, which gives me the square root of x squared plus x plus 1. So remember, for a square root, the inside must be greater than or equal to 0. So find out where that value is 0. So if it has imaginary roots, that means that the value on the inside will never equal 0. And if you looked at this, that also means that it is always going to be positive. So my domain for this is all real numbers. And my range, that one's a little bit harder. You would actually need to graph this to find out what it looks like. When you graph it, it kind of looks like this. It's not a parabola, but it looks kind of like one. But it has a minimum of negative 0.5, 0.866. And it keeps going forever. And so my range would be bracket 0.866 to infinity. I wouldn't ask you to do the range without having a calculator to be able to find that. All right, so number 5, write f of x is the composition of 2 or more functions. So there's 2 ways to do this. The easiest way, whenever you have a square root, is you let the inside equal your one function and the outside equal the other. So we're going to say f of x equals g of h of x. My inside is going to be this. So h of x equals 1 over x squared plus 2. And my outside is going to be the square root. So g of x is square root of x. So what happens is when I find composition, I plug that in there and it becomes my new function. So that's kind of what it's asking. Sort of asking you to think backwards. All right, number 6, a function has these values. So that means 2 points on the graph are 2, 5 and 4, 5. So on the inverse graph, it's 5, 2 and 5, 4. Inverse is not a function because it has repeating x values. All right. Given each fact about one of the functions below, write a fact about the other function. So f of 1 equals 2, which means f inverse of 2 equals 1. So f inverse is the way that you write the inverse function. And remember, the y becomes your x and the x becomes your y. So if f inverse of negative 3 is 5, that means f of 5 is negative 3. Domain is this, which means the range of f inverse of x is 0, 1, 3, 5. And then the domain of that, so that means the range of f of x is negative 3, 0, 2, and 4. So again, this just continues with the idea of just all you do is flip-flop x and y. And this is very straightforward and simple, but you've got to think a little bit outside the box. All right, if f of x has x equals 0, that means it's the point 3, 0. So the function inverse is got a point 0, 3, which is a y-intercept. And then vice versa, it's a y-intercept at 0, 4, so the inverse has a 0 or an x-intercept at 4, 0. And then 8, you can just fill in the table using all that information because you have all those ordered pairs. And then 9 is similar, so I'm going to let you figure that out. 10 we've kind of already talked about. If you know the domain and range of the function, to find the domain and range of the inverse, you just flip-flop them. And then 11 is more composition of functions or operations on functions.